Hi guys, today we will be doing some area into volume and shapes, also known as some geometry. I know, try to hold in your boos. Not that I can hear them because I'm recording this, so boo if you want to, I guess. So anyway, let's just jump right in because I really don't know how to prepare you for this other than to tell you that. So we start out with, this is kind of, if you think about it, the same concept as the metric system, like however many cups is in a pint, however many pints is a gallon. It's the same thing, and there is even pints and gallons mentioned here, but this time we've got some silly things mentioned, like a jigger and a jack and a jill and a mouthful. So we're just going to see how much of each. We're going to go ahead, we're going to go ahead and put we're going to equal all of these out to mouthfuls because that's the smallest unit, so I know that all of them have at least one mouthful in them, so that way we can all be in the same measuring unit, so we get unity together. So I've gone ahead and put this in a line graph to see how many we have. We've got 2 mouthfuls in a jigger, 32 in a pint, 4 in a jack, 8 in a jill, 64 in a quart, 128 in a bottle, 16 in a cup, 256 in a gallon, and 512 in a pail. So now the question becomes, is if we got 1 mouthful, 1 jigger, 1 jack, blah, 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 so basically one of everything, and we put it in a pail, how much room will be left over in the pail? Will it overflow? How much more can we put in there without it overflowing if there's room left? So we're going to do that. We're going to draw a little picture to do that. So here's a pail. I drew this. Just kidding. It's clip art. I didn't draw this. I can't even draw a circle. I kind of started from the highest number and went backwards, but you can do it anyway. So we've got 512 total mouthfuls in this pail. So the first thing I'm going to do is I'm going to put a gallon worth of mouthfuls in here. So there's 256, and that takes up half of the pail. So next thing I did was we're going to put a bottle in here, and we're going to add 128 to 256, because remember we unified it all by using the mouthfuls, and then we get 384. And the next one I'm going to do is a quart, which is 64, and we're going to add that 64 to 384, and we're going to get 448. And we're going to continue this pattern. We're going to add 32 to 64 and get 480. And then we're going to add 16 to 480 and get 496. Then we're going to add 8 to that and get 504. Then we're going to add 4 to that and get 508. And then we're going to add 2 to that and get 510. So without overflowing it, we could add 1 more mouthful, because if you add 1 more mouthful, it'll probably be equal with the rim, but we all know that doesn't usually last, and it'll spill right over. So we can add 1 more mouthful without it overflowing. So next we're going to look for area and perimeter of triangles, and it is actually super easy. We worked with triangles a little bit last time, and now we're back on it again. So the formula for the area of a triangle is 1/2 base times height. I'm going to kind of explain where that comes from instead of just giving you a formula. So let's take a rectangle, for example. Like, we know the area for rectangle is just the length times the width. That one's easy. So why are we taking 1/2 of that for a triangle? Well, if we look at it, let's draw a right triangle on top of this rectangle. Look, it takes up 1/2 of the rectangle, and that is why we do 1/2 base times height, because if we put 2 triangles by each other, we're going to get a rectangle. So we're just going to now plug in this area formula into this. And this shape right here, this is the height. This is not the height. This is the slant right here. We want to find the height. So thankfully it has given it to us, which is 41. If it didn't, we could use a Pythagorean theorem to find it, but thank God we didn't have to, so we have it. We are spoiled today. So we're just going to simply multiply 41 times 83 and divide that by 1/2, or multiply that by 1/2, sorry, which is just dividing by 2. And we get 1,687.2, and we put meters squared for area. And then for perimeter, it's easy. For any shape, perimeter is the same. We just add up the sides, like we're building a fence around it. Perim, we're going around the rim. So when we add those sides up, we get 193. This triangle is just a right triangle like this drawn over here on this rectangle. So we're just going to plug in the numbers to the formula again, and we don't have to do anything special this time. Like there's no extra height, there's no extra added numbers. We're just going to go ahead and plug it in, and we get 1,642, and that is inches squared again for area. We square. We're finding the square units. And the perimeter, again, we're adding on the sides. We get 222, a beautiful even number. Gotta love it when that happens. Okay, and for this is a scaling triangle. I should have mentioned that already. This is a scaling triangle. This is a right triangle. This is also a scaling triangle. Anyway, so for this other scaling triangle, we don't really have a way to find the height within the triangle because of the way the slant is, or the hypotenuse, if you will, if we want to be fancy and show off our smart methods. So this hypotenuse, which is the longest side, we can't, oops, spoiler alert, we can't really find the height just the way that within the triangle, just because of the way it's shaped. So we're going to go and use it on the outside, and it gave it to us again, thankfully. So we've got 2.6 is the height. So let's just go ahead and plug in our numbers once again. We get 8.1 centimeters squared again, and then around it is 17.8 would be the perimeter. So triangle, finding the area and measurement perimeter of triangles is a simple task as long as they give you the numbers, which they had. So we were spoiled, so be thankful for that. Okay, so now we have this beautiful little shape, and we've got a circle within a square within another circle. Where we would see this in nature in real life, I don't know, but we're going to find this out anyway. So we want to figure out what the distance, which is the largest distance. Is it between the circle and the square, or the circle and the square? Excuse me, which is larger, the area of the region between the circles or the area inside the smaller circle? So is it this area, or is it the area between the circles? So we're going to see which one is bigger. Well, how are we going to do that? I have no idea. Actually, it's really easy. So, well, we know that the length of the square is 10. So I can put this line anywhere in the square I want to, as long as it goes all the way across, and it's going to be 10. So what if I cut that in half? I get 5. And if you look at that cut in half, that makes the perfect radius for the circle. So now we can use that to find the area of the circle. So now let's plug it in. So our area of a circle is pi r squared. And when we do this, we get 25 pi units squared. I just use pi units because I don't feel like dealing with all the decimals of pi. I could have multiplied it out. You can stop here. It really depends on the problem, the question. Anyway, so now let's go ahead and find the area of the larger circle. Well, how are we going to do that? Well, if we look, this square goes diagonally across the whole triangle. So we're going to go ahead and try to find the radius of this now. And how are we going to do that? Well, look, we've got a hypotenuse right here, as we mentioned before, a fancy math word, which is the long side of this triangle. This is a 5, and since this is a square, we know that this is a 5. So 5 squared plus 5 squared is going to equal this radius, square root of 5 squared plus 5 squared, excuse me. So here's our Pythagorean theorem, and we get 50 equals r squared. So now we're just going to go ahead and plug that in. So we've got 50 pi units squared is our big circle. So now let's subtract them, and we get 25 squared, and this is 25 squared. So they're actually an equal distance apart. Okay, so now for this one, we've got a cone. I don't know how they did this, but they did this crazy thing. You might be, building a child's toy. You need to use this formula once in your life. I don't know. But we've got a sphere within a cone, within a cylinder. I don't know what is in what. They're all within each other. Not the point. Anyway, so we're trying to see the ratio between these and see that it's 1 to 2 to 3. So we're not really given like the actual area of it. It's just kind of the formula within the area. So let's go ahead and figure those out. So let's do the cone first. So the cone, the volume of the cone is 1/3 base times height. Well, to find the base, it's pi r squared because the base is a circle right down here. And then when we put this all together, we get 2/3 pi cubed. And what the cylinder is 1/3 base times height. And then it turns into 2 pi r cubed. And then the sphere is just simply 4/3 pi r cubed. And now we're going to divide all of these by the cone to see what the ratio is, because the cone will be the 1. So when we divide the formula of the cone by the formula of the cone, we get 1. And when we divide the formula of the cylinder by the formula of the cone, we get 2. And when we divide the formula of the sphere by the formula of the cone, we get 3. And that proves that our ratio is 1, 2, 3. Okay, so now we are going to find the surface area of these shapes. This is a trapezoidal, excuse me, prism. Excuse me, sorry, I had a little bit of technical difficulties, and the instrument that I had difficulties with was myself. Anyway, so I forgot where I left off, so I'm just going to kind of restart. So this is a trapezoidal prism, because this is a trapezoid as the base. And we can call this a triangular prism, because imagine that, it's a triangle as a base. Simple. So now we're going to find the surface area of these two shapes, and we're going to plug in formulas to do so. Hello, just kidding. There it is. So we're going to have the surface area is 2b plus ph. B is base, p is perimeter, and h is height. And I have color-coded these things. So here's our base, here's our perimeter, and here's our height. Well, height is the only one that we really have it given to us. We have to find the other two. So let's go ahead and do that. So our base is 1/2 a plus b divided by, or times h, which is how you find the area of a trapezoid. Man, my words just gone, but they're back. My cat is talking. He wants to teach y'all about math. I'm so sorry. Anyway, so let's go ahead and plug in these numbers. We get 258 centimeters for the base. And then the perimeter, we're just adding on the sides up. We add 24 plus 12 plus 17 plus 15, and we get 70. And now we can plug those numbers back in. And again, 4 is just right here. It's given to us, so we don't have to try to find anything. And then when we plug it in, we get 796 centimeters squared. Remember, we're dealing with area, not volume. So the surface area is just all the outside that you can touch, basically. So now over here, we got the same formula for this prism. This time it's just a triangle. So we're going to go ahead and go find the base of this triangle. Well, here's the base, the perimeter, and the height. So the base is 1/2 8 times 7, which is 28. So we already did the area of a triangle, so we should know this. And the perimeter, we're just adding these sides, and we get 40. And actually for this side is not given to us, so we have to use our Pythagorean theorem to find it. And once we do that, we get 40. And then now we can go ahead and plug in our numbers. We get 2 times 28, because 20 is the base. We got 2 bases, one on the top, one on the bottom, plus 40 times 7, which 7 is its height that, is already given to us, so we don't have to find. And we get 336 meters squared. Again, this is surface area. It's all the things you can touch. It's not volume, so it's not cubed. And then we are now finding the surface area and volume of this shape. We've actually got 2 shapes, and I'm going to do them both a different way, so you can see that there's multiple ways to find them. Anyway, so for this shape, you can see here's one formula I wrote, and this is a formula for a sphere. Well, there's not a sphere here. Actually, there is. This is a sphere. When we add these two together, like we put those 2 semicircles together, we get a sphere. 2 halves to make a whole. Imagine that. We are so smart. We can figure these things out. We got this. I don't need you to tell me this. Well, it's important, so I'm going to tell you, even if you already know. So now we just go ahead and plug in our numbers. So 4 is our radius, and so now we're just going to plug that right in. Now I used units of pi for this one instead of dealing with the decimals. So I get 64 pi units feet squared. I think that's how you say it. And then, so now we're going to find the surface area of the cylinder, and this is the formula for that. We get 2 pi r h radius, which is 4, and h is 21. So now we're just going to go ahead and do this, and we get 168 pi feet squared. And so we add these two together, and we get 232 pi feet squared. I was going to say feet squared. Okay, so now we're going to find the area. The area of the sphere is 4/3 pi r cubed. When we plug it all in, we get 85.3. Now we're going to find the area of the cylinder, which is pi r squared times h. And we'll plug it in, and we get 336 feet squared. And so the area of the volume, this is supposed to be a V, not an A. So we're going to pretend that this A is upside down and there's no line in it, and it's a V. Okay, it's not A, it's V, volume. And we cube volume. So now we're going to do the surface area and volume of this one, but this time instead of using two different equations, we're going to just put them all together in one big equation. And this one has a cone and then the cylinder, of course. So now our formula for this one is the surface area equals pi r squared plus pi r, s is the slant, so there'd be this 6 right here, plus 2 pi r h. So this 2 pi r h, of course, is the cylinder, and the other part is the cone. So now we plug in our numbers, and again, it's color-coded. And when we plug it in, we get 113.1 meters squared, because this time I decided we're going to use pi. We're going to put it in the whole equation. So now we're going to do the volume. We're going to pretend that this is like a little exponent that's down at the bottom. I didn't know how to do that on my keyboard, so I used brackets. I improvised. So now we're going to have to find this height, and the height is this right here, which is not given to us. And we're using the Pythagorean theorem to find it, and we get 5.7. And then the base of this is the base right here. You know, we just plug in our 2 pi r squared formula, and we get 25.1. So now we have everything that we need, and we can complete our formula. And we plug it all in, we get 119.5 meters cubed. And that is all. We have made it through more math, and now we can take a nap and cry ourselves to sleep at night, or celebrate, whatever you want to do. Thanks all for watching. Have a happy spring break, and I'll see you when we get back.